Hello and welcome back to Calculus 1, section 3.7, the chain rule. I labeled this earlier as one of the most important sections of Calculus 1, and it is, because about 90% or even more derivatives you take will be chain rule. We rarely deal with base functions. Let's say sine x or x squared. Most of the time we have sine x squared or sine squared x or e to the 3x or, combinations of those. So we would need to develop a method to take the derivative of what we call function composition. So let's go back to pre-calc for a second and look at function composition. So what is function composition? Function composition is when you plug one function into another function. Let's say you have f of x to be x squared minus square root of x. So now, what I can calculate is f of 3. Let's do f of 9. F of 9 is 9 squared minus root of 9. That's 81 minus 3 to give us 78. But I can also replace a function inside. So I can replace it with 1 over x, for instance. So in that case, I would have 1 over x squared minus the square root of 1 over x, giving me 1 over x squared minus 1 over root x. So when I have a function given, like this one, I can plug in numbers to compute function values, or I can substitute a different function inside, or the same, right? I can plug in a function, and then the answer would be a new function. Observe that the two functions that were involved here are x squared minus root x and 1 over x. If you look at the result, well, it's neither of the two, right? It's a combination of them in some way. So what is function composition? Function composition, f composed with g of x, is also known as f of g of x, is when you plug function g into function x. So I'm going to actually box this here, and I will say replace every x of f of x with g of x. So that is what's happening for the function composition. That is what is happening for function composition. Now, the skill that we need, which is what we discussed the day one, is the decomposition of functions. So let's compose one more, and then we'll decompose few so we can start the chain rule. Say f of x is given as e to the 2x plus x squared minus 3. And g of x is given as root x. What is f composed with g? Also known as f of g of x. Well, we are going to take f of x as a base, and as the red writing says, replace every x of f with g. Okay, so that's going to be e to the 2, and instead of x, I have to put root x now, plus root x squared minus 3. So what is f of g of x now? It is e to the 2 root x plus x minus 3. The skill that we need for Calculus 1 is to decompose functions. So we are going to take a look at the function, let's say y equals 3 sine of x squared. What is f? What is g? Anyone? A little bit more. 3 sine x. And what is g? X squared. So now, if you replace x of f with g, you will get our answer over there. You can check. So this plugs in here and you get the function. How about y equals 3 sine squared x? What's f, what's g? Very close, but not there. Yes?
Is it f is 3 sine squared x and g is x?
Nope. Yes?
Is it f is 3x squared and g is sine x?
Yes! 3x squared sine x. Now, this one is tricky. It's tricky, and right? It was close at the first shot. The 3 was in the wrong spot. Look, we can rewrite this problem as 3 sine x squared. Right? So clearly, this is the sine x is the inside, right? So that's why sine x alone is on g. Now you need to compare that to the previous problem. And I also want you to compare it to this problem. So in this problem, what you could do is you can do 3 sine x in parentheses and then everything squared for your f to be just x squared and your g to be 3 sine x. So now you have all 3 problems. Now clearly the 9 is different, right? But you can follow the progression. So this is extremely important skill. If you are not able to do this, the section is not going to go well, because you have to have clear in your head layer 1, layer 2, even layer 3, layer 4 as you go through these. Let's take a look at y equals 4 over ln x. F and g. Very good. Very good. Ah, the spice on this one. How many levels do we have? 3 levels. FGH. All right, 3 levels. So for some of you, it will be easier to work backwards. For some of you, it will be easier to work forward. So if you go F to H or H to F, you know, I don't know which way you do this. Whatever it's, right? There's always only one right answer, but. So where would we start? What would be the most outer function to consider? 5x squared. ln follows the same rule as trig, where I can write ln squared as ln x, everything squared. So if I rewrite this, it's 5 ln x squared minus 1, and then this thing is squared because of the, so I can write the square on ln, or I can write square on everything. So 5x, right? 5x squared is where we begin. Now we dig the level in. What's the level in? ln x, very good. And what's the next level in? x squared minus 1. All right, do we all see? We take this and plug it in there, and we take this and plug it in there. Do we all see that motion and the way it builds? So these are the things, if you're struggling with this, spend time with this only to decompose the function. Once you decompose the function, you will be able to do the chain rule. So y equals the square root of sine of x plus 2. Try this one on your own. Consult with people around you.
so judgmental of blue. Yeah.
Okay, so how many layers? 3. F, G, H, good. What's the layer F? Square root of x, good. Next one.
Sine x.
Great, next one.
X plus 2.
X plus 2, great. That's it. That's the enthusiasm. Hello, Saturday class, finally. You all love Saturdays? You all love weekends? That's it. Where's that enthusiasm? Yeah, I mean, look, outside it's disgusting, it's sunny, it's, yeah. Right? Over here, the numbers and equations, you're safe. Right? Ready for chain rule? Yes. So, the way to take the chain rule is the derivative of function composition is you take the derivative of the outer function with g still plugged in times the derivative of the inner function. You could see this one at the beginning today. I showed you in the Calculus 3 class. I did the review. Right? And the Calculus 3 class, when I did the chain rules, right? The blue equation is the one that I just gave you guys in red during the, right? So what are we talking about? Chain rule helps us deal with the problems where we can't simplify the problem using algebra or we are lazy to do so. For instance, if I'm supposed to take the derivative of x plus 5 to squared, let's say, well, definitely I can just expand and I don't have to worry about anything. 10x plus 25. And now I can take 2x plus 10 and I'm done, right? So, sure. But what am I going to do if I have the same x plus 5, but now raised to the 237th exponent? Am I going to FOIL? Right? Efficiency. So in this case, we are going to use the chain rule. I know that the layer F is x to the 237 and the layer G is x plus 5. So I am taking derivatives of these and they're easy because they're basic. Combined, not so basic, not so easy, right? So where do I start? Well, I'm regarding the whole inside as function g, right, for guts. So what is the derivative of that? Well, derivative is clearly, using the n-1 rule, 237 g to 236. And that's x plus 5 in there. Times the derivative of this, which is 1. And the whole thing is done. Let's take a look at another example. The derivative of sine 4x. Well, f is sine x, and g is 4x. So when I plug in 4x, I get sine 4x. So now what do I get? What's the derivative of sine? which is the outer function. It's a cosine, and you have to write the same g. Remember that it's f of g of x. So whatever g is, it has to stay plugged in. Times the derivative of the 4x, which is 4, and the whole thing is 4 cosine 4x. Remember the formula I asked you to forget? The derivative of sine ax is a cosine ax. Right? It's a chain rule. It's a chain rule that does that. Same with e to the x. The derivative of e to ax is, well, f is e to the x and g is ax. So the derivative of e to the x is itself, so e to the ax, times the derivative of ax, which is just a. And you get your a e to the ax, which was the formula you were supposed to memorize. But you see, the chain rule takes care of it. What is the derivative of sine of x squared plus x minus 9? Well, f is sine x, right? And g is x squared plus x minus 9. So what is the derivative? What is the derivative? You have derivative of the outer function times derivative of the inner function. What do you mean cosine times? Cosine without argument is pointless. Cosine of what? Cosine of what? It's the cosine of g of x. And g of x is the whole thing. So cosine of g of x times the derivative of the inside, which is 2x plus 1, for a total of 2x plus 1 times cosine of x squared plus x minus 9. So g, g, g. It has to stay plugged in. So this over here is f of g, this over here is f prime of g, and this is just g prime. You see that g is still plugged in. The derivative of what? Let's go derivative of tangent squared x. What's f, what's g? Very good. And g is? Tangent x. Good. So what is this derivative? Two tangent x. Good. Times, and the derivative of tangent x is secant squared x. So what's the answer? 2 tangent x secant squared x. Good. Can we check this using multiplication somehow? The product rule? Can we?
Yes.
Compute the product rule for this. Product rule. Copy the first times derivative of the second plus copy the second times derivative of the first. Well, aren't they the same, huh? It's mathematics. Great. No coughing. Find the derivative of the square root of cosine x. So what do we have for this one? What is f? Square root of x. And what is g? Cosine x. Great. So now what do we have? Where do I start? What's the first thing? 1/2. Okay, good. So 1/2 and square root of x. You know what? That only works if you memorized that f prime is 1 over 2 root x. But if you don't have that memorized, then you have to do the half thingy. So how about we rewrite this as cosine x to 1/2, kick 1/2 in front, cosine x to the negative 1/2 times the derivative of cosine is negative sine x. That's the g prime part. By the way, that's the chain, right? That's called the chain. And now we fix this. What's in the numerator? 1 and sine, so negative sine x is in the numerator, and in the denominator 2 square root of cosine x. And that will be the derivative. Fun, right? It's a relative term, but all right. The last problem for today. Find the equation of the tangent line at x equals 0 for f of x equals a to the x squared plus 1 minus root x. No, bad. Minus root. Minus minus x plus 1. There you go. Square root of x is not differentiable at 0. We'll talk about that. So I couldn't use it. Oh wait. I have this is for my day today.
It's like the whole day.
The whole day. And I don't do it.
5 times.
This is just, I don't know. This is, I'm thinking this because I'm bored. I'm never bored studying with the green stuff. You know, it doesn't occur to me. And I don't drag the personal supplies of water with me.
No, it's just freezing.
So only like 97% water, and well, everyone else is like 70% water. So he's like 70% water, and you were 97% water. If you want to fold someone, you do what? You're not going to forget to email everyone four times. Just check. Why? Because you might be distracted by other things. I respect that highly. So this Thursday, Ali will go over the exam problems if you have questions. If you can't make the SI, stop by office hours or go to tutoring center. There we go. Yes.
I want to stay after that. Yeah.
After the class?
Yeah.
I think you do the exam. Okay. I'll do it on the fly, it's fine. So the grades go from 34 to 106. No one had 107. But next time, right? You said so. Next time you just want to say or 100 plus, or 90 plus 5, or that's the problem. Whatever I'm so let's say for 60, 40 points, 69,
Okay.
that will do?
It goes very quickly.
No. He's quieter here. Huh? All right, let's take a look at this problem because you guys got really chatty, which means you are done. Every tangent line problem is the same other than the way you take the derivative. We have to take the first derivative in order to find the slope. And in the first derivative, we have this first member to be the chain rule. Derivative of e to the x is itself, so we'll copy the term as is, and then time the derivative of the exponent, because that's the chain, and then minus 1, and then plus 0. So that's our derivative. You can also write it if you want to as 2x e to the x squared plus 1 minus 1. Now, to find the slope m, we are going to use the derivative and compute at the point given to us. Now, that's 2 times 0 times e to the 0 plus 1 minus 1. And I hope you all see that the slope is negative 1. Because this 0 over here, right, the x is 0, kills the entire term. So slope is negative 1. We also need the y value for the function, which is f of 0, the original function, which is e to the 0 plus 1 minus 0 plus 1, and that's 2. Because, no, lies. That's e plus 1. There we go. E plus 1. Because this is e to the first power, so that's just e. E plus 1. That's okay. We can have that. So now what do I have? I have slope is negative 1, and the point is 0 e plus 1. This is like 3.7, okay? Don't let that throw you off. You can find the decimal value for it if you are really interested in finding it. So now y equal mx plus b. Y is e plus 1. M is negative 1. X is 0 plus b. Well, we should see it from here that b is equal to this because it's a y-intercept, but still. So b is equal to e plus 1, and the tangent line is y equals negative x plus e plus 1. You are not used to linear lines having the constants e and pi and so on, but as you can see, you can have that. Again, the e plus 1 can be approximated in terms of decimals to about 3.7, so it's fine. There will be a part 2 of this lecture next class for about 30-40 minutes, because we need to do product rule within the chain rule, quotient rule within the chain rule within the product and the quotient, and then all of them combined in some way. So these problems are going to be long. I will see you all in a week.